So here's our last lecture in Unit 2. It's called Friction and Technology. So friction plays a major role in technology involving designing roads, bridges, automobile tires, athletic shoes, and surfaces of playing fields. Without friction, driving on highways and running on playing fields would not only be dangerous, but simply impossible. So cars need friction to provide traction for steering, speeding up, and stopping. Those grooves that you have on your tires, they help provide, they help increase the coefficient of friction the car experiences with the road. And that helps you kind of hold on to the road as you're turning your vehicle, as you're slowing down or speeding up. They also have treads in them to help water flow away from your tires, so that the friction is increased, so you don't have hydroplaning happen when you're driving on rainy surfaces. Here's a situation where we have a tire driving in a small amount of water. So when driving at a low, safe speed on a wet road, the water in front of the passenger car tire is low, and the water has time to move through the grooves in the tire tread and be squeezed out behind the tire. So in this situation, friction from the road still acts on the tire. However, if the driver starts to speed up and some of the water of the front of the tire will not have enough time to pass through the grooves, this causes the water level in the front of the tire to increase, which in turn causes the tire to start to lose contact with the road. And if the speed of the car continues to increase, the excess water in front causes the tire to start to lose contact with the road completely. This is called hydroplaning, which if you've taken a driver's ed class, you might know about that situation. Cars rely on friction for stopping. Most cars have disc brakes, especially on the front wheels, which operate in a way that resembles the brakes on a bicycle that we talked about earlier. When the brakes are applied, a piston pushes the brake pads toward a rotating disc. The disc is attached to the hub of the wheel, so exerting friction on the disc causes the wheel to slow down. One problem with disc brakes on cars is that the brake can stop the wheel from turning a lot faster than the friction from the road can stop the car from moving. This results in wheels being locked and sliding across the road. So the car skids and the driver is unable to steer the car. So an anti-lock braking system on cars helps prevent this. That's the idea where instead of your brakes being the sole thing that stops your car, you use a combination of the brakes and the road. So instead of the brakes just completely stopping your wheels from moving, they sort of pump stop your wheels to slow them down, so that the wheels of your car, the tires on your car can also experience friction to slow them down. Nowadays, this is all done electronically. So ABS uses a computer to monitor the speed of the car and, if necessary, changes the force on the brake pads very rapidly, allowing the car to slow down without skidding. So discuss the validity of this statement. It says car brakes slow the wheels down, but friction from the road slows the car down. So this is true. The brakes, they slow down the wheels. But by slowing down the wheels, we can end up that rolling friction, which is less than than other types of friction, ends up becoming negated, because now we have the wheels that are not rolling anymore, and the car would end up slowing down due to the friction of the road. Another feature similar to ABS is traction control. So this is kind of the reverse of the anti-brake system. ABS comes into play when a car is slowing down and the tires start sliding. Traction control is used when a car is speeding up and the tires start turning faster than the car is moving. So if this happens, the force of friction decreases and the driver can lose control of their vehicle. So kind of what you see there, where the car loses traction as it's on that curve. Traction control would prevent this. So there are sensors that would detect the sliding tires, and this would be sent to the car's microprocessors, which would then use the ABS system to slow down those wheels. That then helps the vehicle driver maintain control of the vehicle even while it's accelerating. In many sports, the footwear worn by the athlete is just as important as any other piece of equipment used in the game. Sometimes the footwear is designed to decrease the force of friction, as with skates, and other times it's designed to increase that force of friction to help start and stop moving quickly. So here's the idea of a skate. It says the coefficient of friction of a skate blade on ice can be as low as 0.005. At one time, physicists thought that this coefficient of friction was due to a very thin layer of water forming between the blade and the frozen ice due to the pressure of the blade pushing down on the ice. However, physicists have found that a thin liquid layer of slushy water exists naturally on the surface of ice rinks, and the layer gets thinner as the ice gets cooler. It is this slushy layer that reduces the coefficient of friction. So why do skates slide so easily over ice? So the water on top of the ice reduces the coefficient of friction. Why will skates not slide easily over extremely cold ice? As the ice gets cooler, the layer of water gets thinner. Why is the bottom of the skate curved? So the edges help the skater dig into the ice to accelerate. We talked about the use of bearings to reduce friction as well. Bearings are, they basically change from sliding friction to rolling friction. There's less in contact with less materials in contact with each other, so we have less friction happening. Fluid bearings are also used. Fluid bearings can be an oil or an air an oil or an air fluid between surfaces to prevent friction from happening when those surfaces touch each other. Here we're talking again about the how the Egyptians used rolling logs to move blocks, this is the same idea as bearings. Basically, rolling friction being less than sliding friction, they could then move blocks with less force applied, that would make it easier to move those large blocks around the desert. One area of interest currently in physics involves prosthesis design. So a prosthesis is an artificial device that replaces a missing body part. In 2000, researchers in Egypt unearthed what they believe to be the oldest documented artificial part, a prosthetic toe made of wool and leather attached to a nearly 3,000-year-old mummy. This is a good representation of how little prosthetic limbs have changed throughout history. So that's just a curious little thing, and there's a nice little picture there to see that prosthetic toe. Artificial limbs have seen many recent involvements involving new materials that are lighter, more durable, and more flexible than previous materials. However, some people claim that these new materials and designs actually give an amputee a physical advantage over other athletes. There's some stories about that you can kind of read about, but we won't go through that in this course. Common use of prostheses today is the artificial hip. What characteristics do you think the materials used in a hip replacement must have to be able to function properly? Well, you would want to have a low coefficient of friction to reduce wear on that hip joint. That's one of the main things. Another area of interest is making materials that have very low coefficients of friction. So Teflon was a big development that had a low amount of friction, but now they've found materials that have even less coefficient of frictions than Teflon. Near frictionless carbon, for example, has a coefficient of friction that is less than 0.001. which is less than what Teflon has. And here's our last slide for the lecture and for the unit. Just a summary of some interactions between friction and the technology we've developed. I'll just go through them quickly. Tire treads, so they help move water through your tire so that the water gets dispersed to prevent hydroplaning. They also kind of increase your friction so that you can grab onto the road with your car. Disc brakes on cars, they slow down the wheels of your car, just like how bike brakes slow down your wheel. ABS, an anti-braking system, uses a computer to prevent brakes from locking up and causing you to slide when you're trying to stop. Traction control, it basically kind of operates the ABS when needed to prevent your vehicle from, or turns the brakes on to prevent your vehicle from sliding as well. In sports, you have footwear that's designed to either increase friction, like running shoes, or decrease friction, like skates. Bearings are used to reduce friction. We have ball bearings, which are common, but there's also fluid and fluid bearings, which can be an air fluid or liquid fluid. And lastly, it says here, new research involves prosthesis design and materials such as near frictionless carbon. So that's it for this unit. If you're having any questions before you start the final test for this unit, you can ask them on our class discussion board.